Hello. So, we have just discussed the ML on GPU web app and how it basically works. So, in this demo, I'm just going to show you what is actually happening behind the scenes when these parameters that are entered into the web app are received. So NuNet has a device management service that we are developing. So what that would do is it would use Docker to run that particular job on a GPU in the system. The system is an onboarded machine that has been onboarded onto the NuNet network. So let us just have a brief understanding of how this Docker container is working. So first we are specifying the docker run command to run this job, and we are also specifying the GPU specific, like we are giving the GPU specifics. We are saying that run this, we are giving the system, we are giving the Docker system permission to see the GPU so that the job is being running on a GPU. So this is basically our GPU-ML container that is based on the TensorFlow framework. And basically this is the ML on GPU web URL that we saw in the first parameter of the compute request, the ML on GPU web app. And as we just discussed about the matplotlib, this is the second parameter that is being entered into the container. So this is how it is working. So I've just pressed enter, and what is happening in the background is the job is being fetched, and job is now started running. So we have 100 epochs for training the data set. So this is running on an RTX 2060 NVIDIA GPU, and here we can see that the available amount of GPU video memory that is available for the job to run. So whenever we are starting the job actually, so the available video memory would be used. So this is the 2060 is basically a 12 GB card. So at the moment the system had been using the remaining part of the video memory, so it has allocated whatever is available. And let us, while the job runs, let us quickly have a look at what the program is doing. So this is basically a fashion MNIST based program. So what it is doing is it is distinguishing between different types of objects and trying to identify which one is having the right kind of label. Basically what it does is it tries to identify that the t-shirt is a t-shirt and not something else. So for example, there could be errors when the machine learning code is trying to differentiate between a t-shirt or a shirt. So there might be errors in that. So depending upon the accuracy, the predictions would be made. So this is basically the code that is running inside here, and we are using the keras library that is already inside TensorFlow. The PyTorch based model also works in a similar manner. So this is what we had specified here to run the TensorFlow job. So let us have a brief look at while the job is running, let us have a brief look at the device management service. Let us quickly look at the wiki. So these are the things that are being implemented by the that we are going to implement with the device management service. So in the background, the device management service will be running in the Docker container with on the GPU. And let us quickly observe how the GPU is being detected, and also the secure boot detection, because there are many systems that have secure boot enabled, and the driver needs to be signed and there needs to be a reboot. So we have included a feature to detect the GPU and also look for a secure boot. So how we are doing that is, first we are checking whether there is a GPU or not. If there is a GPU, then we say that then we check whether the driver is installed or not. If the driver is installed, then we skip the installation and do the secure boot check with this code. We call this function over here, and then we basically install the driver if the driver is not there. In case the secure boot is being used, is enabled, the system needs to be rebooted, and then the driver would be installed, would be available for use with the GPU, and then we would also need to, but that reboot can be done after the installation process is completed. So then we could then we install the NVIDIA container runtime, and then we just restart Docker, and then we have it installed. So we currently have support for Ubuntu and Kali Linux. So basically the job is now completed, and we have a test accuracy of 0.88 approximately. So that's the basic demo of the TensorFlow code that we just tested. So thank you.